So let's continue. Let's review this. Now, the rules are clear the parentheses first, and that means usually distribute, if you have to. On each side of the equals, each expression, if there's like terms, combine them, so do that first. And then it becomes a relatively easy thing to do. If there's variables on both sides, use an add or subtract step to move it to one side or the other. Then usually there's another add or subtract of a number, and then a multiply or divide. So let's see what we do here. Let's distribute first. So that's 3x plus, what's 3 times 12? 36. Okay. Minus x. That's one side. Now I'm going to clear these parentheses by distributing. 4 times 2. And then a 4 times a negative x. Negative 4x. Minus 3x. Where are we confused?
I didn't know where we were.
We are on the bottom of finish 3, bottom right. Anybody else not know where we are? Question? Yes, you look at this side and you say, are there any like terms? 3x minus the x. Remember like terms? You look for, you circle with the minus. If you have 3 x's and you take an x away, how many x's do you have? 2 x's. Plus the 36. Now let's look over here. Now I've got a lot of x's here. A minus 4x, a minus 3x, plus a 2x. So I'll just put my 8 here. Now minus 4x minus 3x, what's that? 3x. Minus 7x. Minus 7x plus 2x. Minus 5x. Minus 5x. So some of you guys are real good with the extra math. If this is still an issue for you, put in your calculator minus 4, minus 3, plus 2. If you still can't work with these integers. Okay, now look how much simpler it is already. And so your goal is complicated, less complicated, less complicated. Yes, ma'am?
Why did you drop the...
What did I drop?
On that...
This one?
Yeah.
Where's my 3? I distributed. I said 3 times x is 3x, and 3 times 12 is 36, minus x. Oh, I said here I have 3 x's and I take an x away. How many x's do I have left? 2 x's. So that's the combined like term step. Are we okay here to here?
Yes.
How did I get to 5x? So I had a minus 4x, minus 3x, plus 2x, right? That's this. So remember, with the x's are all the same, so it's basically minus 4, minus 3, plus 2x. So minus 4, minus 3 is minus 7, plus 2 is minus 5. Please ask these questions, because I want to make sure this is clear. And because it should start looking easier now. Now what do I do? Yeah, what can I do?
Oh, you do minus 2.
Okay, let's do it that way. So you said put it over here.
Yeah.
I'm going to go the other way, but it doesn't matter. So 2x minus 2x is 0 plus 36 equals 8 minus 5x minus 2x. Minus 7x. Now we're going to subtract 8. Why am I subtracting 8? 8 minus 8 is 0, right? I want that on the other side. Subtraction property of equality. What's 36 minus 8?
28.
Now, see this minus? It's still here. 8 minus 8 is 0 minus 7x. Should be easier now, right?
Yeah.
Divide by negative 7, divide by negative 7, x equals negative 4. Now, I turned it around. I used that symmetric property of equality, so my x is on the other side. Now, did we follow that?
Yeah.
Did everybody, because everybody, the people are like, yeah. There's some people who are like, no. Yes.
For 8 minus 5x, when you're taking away 2x, what did it become? 7.
Because I had a minus 5, minus 2. Minus 5, minus 2. Signs are the same. Add it to the side. No?
You're adding 2 minus 1 of the
Right? These are working with integers. When did we do integers? numbers last year?
Yeah.
That last year? They can be confusing when you're adding, subtracting with sign. The rule is same sign, add, keep the sign, right? Opposite, subtract, sign is a bigger number. If this was still like, I could not do that last year and I still can't do it. This year you do have a little help. There's a calculator sitting right here. Even if it's just to verify, I would like you to get good at it just seeing it. So try it and verify it with a calculator if this is something hard to you, rather than just get it wrong if you didn't add it correctly. Okay, other questions? Great question. Other questions? It's a lot of steps, but do it. Now, if you kind of have to rewrite each little piece. Don't try to do it up here and crossing whatever. Sometimes we do it very sloppy. You should be plugging this back in and checking it. Interest of time, not doing it, but you should be doing it. Okay, so this is new here, this idea of special cases. So I'm on page 4 now. Let's look at this one. Without looking at the paper, first just look up here. So let's solve this thing. So we said the first thing you do is clear parentheses, right? So 2x plus 6 equals, that's 2x. 2 times a positive 3 is a positive 6. Some people may say something that's kind of strange here already. But, okay, so I want all the x's on one side, right? So I guess I'll subtract 2x to move that over. Oh, there we go. So 2x minus 2x is 0 plus 6 is 6, right? And 2x minus 2x plus, wait a second. Where'd the x go?
It disappeared.
Where'd the x go? It's gone. 6 equals 6. Well, yeah, I guess it does. That's true. 6 does equal 6. So what just happened here? Oh, this is weird. You know what's happening? What's happening? What?
The x's on both sides of the equal were the same value.
Yeah.
So when you cancel them out, they both canceled out.
Right.
And all that was left on both sides was the sixes.
So what's the solution to this? What is x that makes this true? What? Well, why? He's saying all real numbers. Anything. Pick any number. Somebody pick a number.
34.
Let's pick an easy number.
813.
7? Let's pick 7. Put a 7 in here. 2 times 7 is 14. 14 plus 6 is 20. All right, put a 7 here. 7 plus 3 is 10 times 2, 20. 7's a solution. Pick another number. Pick an easy number.
809.
Easy number. 4.
Yeah.
4. 2 times 4 is 8 plus 6 is 14. 4 plus 3 is 7 times 2, 14. That works too. Or 4, that was 4, right? How about 0?
7.
0, you get 6. You get 6.
74.
Any number, any real number that you can think of, you plug it in. It works. If, what? No, the answer is, remember what we're looking for. We're looking for the solution. What values of x make this true? So far, we just picked any 3 numbers. They all work. You can pick any number you want. They're all going to work. All of the real numbers will work.
Will it be exponential?
Nope. Nope. It's just 1, 7, 2.3, pi. Just stick pi in there. It's going to work. All real numbers. All real numbers. So when you are solving and you see the x disappear and you get a true statement, right? 6 equals 6 is true. That means no matter what you put in here, you'll get a true statement. And all real numbers are the solution. So this is one possibility of a special case when you're solving with variables on both sides. Sometimes weird things like this happen. Now the other thing that can happen is this. So I've got 3x equals this, so let's solve it. 3x equals 3x plus 12. I want x's on one side, right? So I'm going to subtract this 3x. Oh no. What's 3x minus 3x? 0. 3x minus 3x is 0 plus 12. Seriously? What? First of all, where are my x's? Gone. And 0 equals 12. Really? Is that true? No. 0 is not 12. That's a false statement. So what's happening here? What's happening? What did I do?
There's no solution to the equation.
There is no x in the real number system that will make this work. Nothing. There is, and think about what's going on here. You've got a number on one side and that same number on the other side plus 12. same number anymore. This has no solution. So the situation is when you're solving an equation with variables on both sides, three things can happen. So first thing is you get an x equals some nice number. It works. X equals 4, 10, -6, right? It works. Or the x's, while you're solving it, they're gone. And you're left with a true statement. That means that any number you can think of will work. All of the real numbers are solutions. The third thing that can happen is there's no solution. There's just no x that will make this thing work. These are the three things that can happen when you have variables on both sides. And I see, if you notice this, what they look like is you have the same variable in front of the x, or the same, same coefficient, you know what that is, same number in front of the x, plus maybe something else. And with the all real numbers, look how it matches. 2x plus 6 equals 2x plus 6. If they match, isn't it true? Any x you put in here, it's going to be the same. Yeah. So you can get a little clue when you're doing it. And let me see if I have an example here. Oh, yeah, I'll have to do that too. But anyway, that's it for the variables. These proportions, I usually fly by it. You know why? You're supposed to know how to do this already. How you solve a proportion, two fractions equal to each other. You've done this, I know you have. Yeah, what? What do you do? Cross multiply, what's that? This equals that, right? Who remembers doing this? Because for some reason, nobody can do this ever. These are proportions. So you say 2 times x equals 3 times 4, which is 12. And this is not possible to do. Right? So x equals 6. We can verify this. You put a 6 over 4. Is that true? Well, let's reduce that. Yes, it works. What?
I don't do that way. What I do is I do 4 times 3 is 12 divided by 2 is 6.
Why do you do that? Is this the is over up thing? I know some.
Our teachers taught that last year.
They just say blindly do that, right? Blindly, just multiply and divide it. Did they say why? So what are you going to do when you get one like this? What do you do when you get one like this? Does that still work? Does it still work?
Yeah.
Picking on him. I'm picking on you. Just say this type that, divide by that. So instead of doing this blindly, cross product. I think Ben said those magic words. Cross product. The numerator of this times the denominator of that equals the denominator of the first one times the numerator of the second. This times this equals that times that. So it looks like a little x, like a cross. Now let me go back up here. The trick to this, is everybody listening to the trick? Because for some reason we can't do this and I don't know why. So to everybody listening, your eyes are riveted up there. If you're sleeping, you're just shaking yourself away. You're looking, right? Who's looking?
I'm looking.
Hands up, you're looking.
I'm looking.
Who doesn't have their hands up? Okay, yeah, okay. We're all looking. Watch this. When you have a fraction, and this is called a binomial, don't worry about that. It's got more than one term in it. Put it in parentheses. Who heard me say that? Raise your hand if you heard that. Who needs me to say it again? Raise your hand if you need me to say it again. Okay. So if you have a fraction, and there's more than one term here, put it in parentheses. The most important thing to take away from solving a proportion. You got that?
Yeah.
Cole, you got it?
Yeah.
Okay. So now when I do this times this, and always put your number first, that's 3 times x equals 2 times this thing in parentheses. This thing in parentheses. I can't say it loud enough. Because for sure I'm going to get a paper. I didn't put it in parentheses. Put it in parentheses. Because isn't that different than this? Right? This is not the same as that. Distribute. Right? Now subtract 2x, subtract 2x. X equals 2x minus 2x is 0. Did we follow that? Is that hard? Is it hard?
It is not hard.
Are we listening? If you're not listening right now, you will not know how to do this. If you're doing something else right now, you will not know how to do this. Yeah. Okay? If you have two fractions, this times this equals that times that, group the numerators and denominators. Group them. And I have it on your paper. See it? It's in capital letters. Can you find this on your paper? Sit down. Everybody sitting. Go ahead. Move. Sit down. Right there. So, see where it says remember to group numerators and denominators, use parentheses. Everybody find that on there?
Yeah.
Put a big box around it and put stars around it. It's on page 4, right? We're all on page 4. Right here. Make a big box with stars.
Oh, I did how to do this.
Have we done that?
I don't.
Did you all write this example down? See where it says on your paper x over x plus 1 equals 2/3? Did everybody copy this down? If you didn't copy it down now. Put the parentheses around the x plus 1.
Oh, wait, here.
And I'm going to do another example. Are you ready?
Yes.
It's right here. That's the workboard. That's why you guys have to stay with me when I'm going through this. Right? 3x equals 2 times that. Write it down, write it down, write it down. We got it? Everybody's got this copy down, because I'm going to turn the page. I want to do another example. All right, how am I going to move you guys? Let's see. Maybe Max will move down one. And Cole, you can sit in that front seat right there. Because I'm tired of it. I'm just tired of it. Okay. Let's do another example of this one. I'm going to do K. So if you look on the back there, see K? So what should I do first? What should I do first, Ben? Not yet. What do I do first, Claire? Then you just put a big box around it.
X minus 8.
You put the x minus 8 in parentheses. Do it! Put that x minus 8 in parentheses. That's what you do first. Everybody putting that thing in parentheses? Everybody know where we are?
Yes.
Then what then? So 8 times, in parentheses, x minus 8 equals 4 times 2. I went like this. That thing equals that thing. Now let's do our distribution. Right? Group this over 4. So 8x equals 8 plus 64. I want to say 72. Is that right? And then I divide by 8. Another way to do 8 times x minus 8 equals 8. When I did this myself, I did not distribute. What's the other way of kind of handling this? There's another way. Oh, I think this was the huge method. What was the other way to handle one like this without distributing?
Oh yeah, divide by 8.
Divide both sides by 8. 8 over 8 is a 1. 8 over 8 is a 1. So x minus 8 equals 1. Add 8. These are both correct methods. I do it this way unless I can make a mistake. Either way. Either way is fine. I'm going to just do what is, excuse me, what is with all this noise? What is the first step for L? What do you do? What do you do? What do you do? What do you do? Every hand should be up. What's the first step? First step. 8 ones. First step.
Go for number 1.
For L, right here. First step.
You put the 21 in the
Excellent. I'm just going to set this up and you can solve this on your own. So then what? cross product, cross product. 2 times this thing in parentheses equals 5 times that x. And now it's an equation that we solve, variables on both sides. Are there questions? Can we solve these proportions now? Yes. Yeah, finish it. Go ahead and finish that one. Why not? All right, see what you get. And when you finish that one, try letter I. Huh?
So as you get 22, and then
We have 42 minus 2x equals 5x. You know that?
and then we just subtract.
Add 2x. Right? Why am I adding 2x? I have all the x's on one side, all the numbers on the other. Divide by 7, divide by 7. I got x equals 6.
After algebra,
Do I? Now, fraction here, that's okay. You try I once you've gotten this out of the way. Should have gotten x equals 6. You got one right? Yeah.
L.
I, right? Oh, you got L, right? L should be what?
6.
I did. Let's try letter I. So we distribute, right? 6x plus 4. Half of 12x, 6x. Plus half of 8, 4. So you already see what's going on here? Same thing on one side, same thing on the other. If you plug x's in, won't they always be equal to each other? What is this one?
all
Andrew,
could be right.
Oh my goodness.
Numbers.
All real numbers. Now you could have, maybe you didn't notice it, you started subtracting. You would get, well they both cancel, 4 equals 4, it sure does, that's a true statement. All real numbers. Let me see if you can do, where is E? I think E's on this other page. Try letter E. Try letter E. Let me see here. 2 minus 15x equals y times negative 2x. 5 times positive 2. Alright, let's see here. Now you may notice something already. See the negative 15x, see the negative 15x, but different numbers? That's a clue. But let's see, I'm going to add 15x to both sides, and then what's going to happen to my x's? They're gone. Disappear. They're gone. And what's left? I've got a 2 on this side. That's ridiculous. 2 equals 10? What? No solution. Excuse me. Now, here's what I don't want you to do. And I know this after teaching algebra for several years now, many years. When you can't figure it out, let's say you're working one like this, you just, I don't know, I can't figure it out. It's not no solution. Just because you're having trouble figuring one out, don't write no solution. It is no solution when the x's are gone and you get a false statement. That's the only time you should be writing down no solution. You will be tempted, I don't know how to do this one and I'm getting confused. No solution. Don't do it. It's only in this situation.